Alright, back with 25E, questions 10 and 11. Not going to be a huge focus of what we're doing, but should probably still have a little bit of an understanding. What you're really going to do is write down the rules I'm about to show you on your summary sheet, and that'll probably be enough to get you through if there are any questions on this stuff. But let's just have a quick look anyway. X is distributed with a mean of 6, standard deviation of 2. Y is the same distribution where every score got doubled and then had 5 added to it. Why that happened doesn't matter. Find the mean and the standard deviation of the Y distribution. Now, you could go straight to these rules, or you could just use your head. I'm happy with either. If I was just going to find the mean of Y, well, if we double every score and add 5, then the mean of X would be doubled and have 5 added to it. So that's exactly what this rule here says. If you have an expected value of some sort of change distribution, you multiply the expected value and then just add the constant. So let's go ahead and do that for Y. Ooh, that was pretty interesting. I don't know what popped up there. I'm going to investigate that later. But here we go. The expected value of Y equals the expected value of 2x plus 5, which is 2 times the expected value of x plus 5. So that's 2 by 6 plus 5, 12 and 5, 17. Now, the variance, remember the variance is obtained by squaring the differences between each score and the mean. So when I multiply each score, when I square that, this factor that I've multiplied by then gets squared. That's why there's an a squared in the front there. So let's go ahead and calculate now the variance of Y. So the variance of Y is going to equal a squared multiplied by the variance of X. Now, we've got to be careful here because they haven't given us the variance. They've given us the standard deviation is 2. So the variance, of course, is going to equal 4. So the variance of Y equals a squared, which is 2 squared, multiplied by 4. The variance of Y is equal to 16. Great, but they didn't ask us for the variance of Y. They asked for the standard deviation. So we just go back and find the standard deviation by square rooting again. Complicated procedure to get there, but the standard deviation of Y, I should make that clear, is just 4. So you can see what's the shortcut way of getting there? Just square the standard deviation would have done it. Will it always work? When it's 2 it will, but not always otherwise. So there you go, pretty easy and straightforward. Hope that helps. Let's go on and look at question 11. Same sort of thing. Gone a little bit too far there. Let's come back just a little bit. There we go, that'll do. Move my ugly mug out of the way. And let's keep going. So this is just using those same properties again. The mean of a distribution is 3. Find the mean of the Y distribution where we've got this. So for the first one here, for part I, the expected value of Y equals the expected value of 3x plus 4, which is just 3 times the expected value of x plus 4. The expected value of x was 3, so it's 3 times 3 plus 4, 9 and 4 equals 13. Same procedure again. This time I've multiplied each score by -2 and then added 1. Doesn't change anything. The expected value of Y, skip a little bit of work here, it's going to be -2 times the expected value of X. Then we add 1, so it's going to be -5. For part 3, Y here equals 4x minus 2 over 3. Let's just make that a little bit easier for us to use given the current rules. So it's going to be 4/3 of x minus, getting carried away there, 2/3. So the expected value of Y is going to be the expected value of all of that, which of course is just 4/3 times the expected value of x, which was 3, minus 2/3. So I'm going to have 4 take away 2/3, or 3 and 1/3, not negative, just 3 and 1/3. There you go. Again, not a huge focus, but now you've seen them, you know you can deal with them however you want to. And if you want to just make sure you got that rule down, then if they turn up, you'll be able to cope with them. See you in the next one.